hydrophobic signal. Hydrophilic, and you know that how? Yeah, it doesn't enter the cell, the receptor's on the surface. It would be much easier to have the receptor inside the cell if we could, but we can't. Okay, so that's why it's on the outside. So here's a hydrophilic one here. It's going to bind to something that triggers a response. This arrow right here really probably is more of a multiple step pathway. It doesn't have to be, but it often is a multi-step pathway. And most signal transduction pathways are many, many steps, and they involve this second messenger like we talked about. All right, so let me show you, this is general, and we'll use some of these actually throughout the rest of the term. Let me show you some general kind of protein ligand interactions we have in context here. These receptors are proteins. These are ligand here is most often a protein, but it means it's just hydrophilic. So this is going to have specificity. This will show competition, saturation, all of them. Okay, infinity. So let's look at some classic examples. These usually fall into 4 different categories. And this summarizes those 4 categories. And let me just show you them real quick. Sometimes the receptor is linked to a channel. Okay. The channel is gated. So this channel would be what we call a chemically gated or a ligand gated channel. Without the signal, the channel's closed. When you get a signal and it binds right here, the channel opens. And then what do you get? Well, you get ion flux, right? Ions are going to move. As ions move, that's the cell response, right? The cell is now different than it was before we had this. How it's different depends. It could mean that it generates something called an action potential. It could mean that it triggers the release of something inside the cell. But this opening of a channel creates a intracellular environment that was different than it was before we had the signal. And that's the response. We'll see some specific examples, and it really depends on what the specific scenario is we're talking about. This is simple. Does this involve a cascade? No. Is there a second messenger? No. Is it pretty simple? This is just a ligand-gated channel. But it's still, this is a hydrophilic signal. This is a protein receptor linked to a channel. Okay with that? Lots of examples of those. Pretty simple. Okay, and we'll see some in context. This is also an incredibly common scenario here. Notice how we have the receptor linked to an enzyme. So we're going to call this a receptor enzyme. Okay. Protein. In the absence of the signal, it could be that the enzyme is inactive and it's not catalyzing a reaction. Okay with that? Could be we add the signal, binds to the receptor, activates the enzyme. And then the enzyme does what? It catalyzes whatever the reaction was. What could that reaction be? I don't know, it depends. The most common example here, this enzyme is called tyrosine kinase. And we abbreviate it TK. Incredibly common TK enzymes. Okay. Tyrosine's the substrate. Kinases do what? They put phosphates on things. So anywhere this enzyme sees tyrosine, the amino acid tyrosine in a protein, it puts phosphates on. And what did that do? Well, that changed whatever that protein was, right? And in fact, what it probably did was it activated that protein. And then that protein does something. That's the cellular response. But you see here, no receptor, one scenario. I'm sorry, no signal, one particular cellular environment. Add the signal, bind, activate this, catalyze reaction, something happens. Did this involve a cascade? Probably, right? You bind, you activate this, that activates something else, then you get a cellular response. It's probably not what we call a second messenger, although it could involve one. It's probably just more direct activation or inactivation of protein. Very common TK receptors. This one right here, however, is probably the most common kind of hydrophilic signal protein receptor interaction that we have. It is called a G protein coupled receptor. Okay. So I'm just going to call it GPCR.